students, welcome to our chemistry class. Our chapter name is metals and non-metals. A small portion is left in this chapter and today we are going to discuss that topic. In the last classes we discussed about physical properties, of metals and also non-metals. After that, we are on the topic chemical properties. Some of the chemical properties we already discussed. Which are they? We discussed about reaction with oxygen. That is the first one. Then we discussed about reaction with water. These are the two things we discussed in the last class. And also we want to discuss about the reaction with acid and also reaction with base. In this area we are just studying very little things and you will study these things in detail in the 10th standard. Now we are going to discuss the reaction of metals with the acid, reaction of non-metals with the acid and also with the base. So that is today's topic and these all things we already discussed in our previous classes in Google Meet. Now we are going to conclude this chapter today. The first topic is this reaction with acid. Reaction of acid with metal. Now I am just taking one test tube and collecting some dilute acid. First of all, I am collecting dilute HCl. HCl means hydrochloric acid. Hydrochloric acid, HCl. And after that, I am just putting one piece of metal in this. And observe what is the reaction takes place in this test tube. That is the thing we are going to do. And for this experiment, we want to collect different types of metals. The metals are sodium, magnesium, aluminium, iron, zinc, copper. Like different metals we are selecting to study the reaction with the HCl, hydrochloric acid. This copper is having some different result and so I am just removing this copper from here and now we are selecting sodium, magnesium, aluminium, zinc and iron. So, when we are putting a particular metal in this and we observe it after some time, you can see that therefore bubbles in this. Therefore bubbles. These bubbles are formed. What it means? It means that they produce certain type of reaction or there takes place certain type of reaction. That is the meaning of the formation of these bubbles. So that means here number of bubbles are there and they produce certain type of gas. There is producing certain type of gas. Now the question is what type of gas is produced in this? Is it hydrogen, oxygen, nitrogen? Which gas is formed here? That we have to find. For that, I am just doing one thing. I am taking a matchstick, burning matchstick, and hold this matchstick at the mouth of this test tube. Then you can hear a pop sound. A pop sound. When this burning matchstick produces pop sound, they produce the gas called hydrogen. They produce the gas called hydrogen. So, here for the gas hydrogen, and that hydrogen gas we can see as bubbles on the surface of this metal. So, here we study the reaction with sodium, magnesium, aluminum, iron, zinc. So, certain metals, they may do not get react. Then what we will do? We will heat this dilute acid. Then it will start getting react. So, the rate of getting reaction is different for different metals. Some metals are very slowly reacting and some metals are very fast reacting with acid. And now the question is, what about the copper? When we are putting copper here, copper metal in this dilute HCl, what happens is that there is no such bubbles are forming. That means there is no reaction takes place with the dilute hydrochloric acid with the copper. And I already said that when we increase the temperature, that means when we give heat to this mixture, then what happens? The reaction increases. Then, now in this test tube, there is having copper metal and dilute hydrochloric acid. When I just put a burner here and heat this, and again observing, do there any bubbles are formed? No, still even after heating there is no reaction takes place for this copper. So for other metals, they get react with hydrochloric acid, but for this hydrochloric acid, copper is not at all getting reacted. But this copper will get react with sulfuric acid. H2SO4 is what? Sulfuric acid. For the sulfuric acid, this copper will get react and you can see the bubbles and also therefore hydrogen gas. So, you just want to understand that for each and every acid, the reaction, the rate of reaction, everything will be different. And we can write the reaction with the acid and the metal with a general equation as, the general equation is like this: when the metal is getting react with dilute acid, we get the result as salt plus hydrogen. Salt plus hydrogen. That means when this metal is getting react with a particular acid, we already said that there is having hydrogen gas, and also there is one another product, and that is one salt. For example, for the hydrochloric acid, the salt formed is metal chloride. Metal chloride. And when we are talking about sulfuric acid, H2SO4, then the salt the form is metal sulfate. Metal sulfate. That is, for the hydrochloric acid, the metal salt the form is metal chloride. And for the sulfuric acid, the form metal sulfate as the salt. And now you just want to study this as a general thing. And you will study this in detail in your next classes. That means in your 10th standard and all. So this is all about this. I think it's clear for you. This is all about the reaction of acid with metal. Now we are going to discuss with the reaction of acid with non-metal. This reaction with the metal is over here. Reaction of acid with non-metal. Non-metal. So for this, in the similar way, we are selecting certain type of non-metals. Charcoal, sulfur, etc. We are just selecting certain type of non-metals. again I am taking one test tube, filling this with dilute acid. I am just selecting dilute hydrochloric acid, and the same manner I am just taking a piece of coal and put it in this acid, and I am just observing what happens in this. After some time, we don't see any type of bubbles or the foam. That means, already said that there is no bubbles means what? There is no gaseous forms. That means that there is no such reaction happens. And also when we touch the test tube, there is no heat is formed. That means there is no such reaction takes place with acid and non-metals. And also we are checking this with a matchstick, a burning matchstick, and observing, do we are hearing that pop sound? There is no such pop sound is formed with non-metal. So we can generally say that non-metals do not react with acid. Non-metals do not react with acid. So now the reaction with the acid, I am going to conclude this here. For the metals, there occurs reaction and they form what? Salt and hydrogen gas. Salt plus hydrogen gas. And also one thing is that for the test tube, when they filled with dilute acid, and when we are putting certain type of metal in this, I am not talking about the copper, any type of metal is there. For example, I am just taking the zinc. Then when you test the test tube, you can feel the heat here. That means here for one product is heat also. That means heat energy is released in the reaction between the acid and the metal. In the non-metal, there is no such reaction occurs. There is no bubbles form. That means there is no hydrogen form. Then there is no salt is formed. And also there is no heat also forms. For the metal, therefore, salt is there, hydrogen gas is there. So you can see the bubbles and also you feel heat the produced. So this is all about the reaction of acid with metals and non-metals. Now we are going to discuss the next topic, that is the reaction with the base. Reaction with the base. Reaction with the base. Here I am selecting the base as sodium hydroxide. Sodium hydroxide. The chemical formula is NaOH, sodium hydroxide. This is a base. And here, first we are going to study the reaction with the base and metal. Reaction with the base and metal. So, again I am just selecting one test tube and taking some sodium hydroxide in this, and I am just putting some piece of metal in this and observing this, what happens in this test tube. And when we observe this again, you can see that there forms certain types of bubbles. Some sort of bubbles are formed on the metal. So what it means, here also certain type of gas forms. Then I am doing that, just take a burning matchstick and put it here. Here also you can see a pop sound, and we can finalize that when the base is getting reacted with the metal, they'll form a gas called hydrogen. Hydrogen gas is formed here. Here hydrogen gas formed with the reaction with the metal and the base. So we can generalize the equation as when the base is getting reacted with metal, then you get the result as salt plus hydrogen gas. Hydrogen gas. So this is the general equation or the reaction for the base is getting reacted with metal. So you want to study this general equation, how the base is getting reacted with metal. So this is all about the reaction of base and the metal. Now one thing is that when we are talking about the reaction with the base and the non-metal, that is reaction with the base and non-metal, actually the process is something complicated and there is not the topic is there in your syllabus, so that you will study later. So this topic is finished here, and after this you want to study one type of reaction called displacement reaction. This is the last topic in this chapter, displacement reaction. Displacement reaction. This is a type of chemical reaction. There are different types of reactions are there, and this is one of them. And you will study all type of reactions in detail in your later classes. So now we are going to discuss what is this displacement reaction. For that, I am just collecting 5 beakers. And I am taking certain type of solutions in this. Beaker A, B, C, D and E. In the beaker A, I am taking CuSO4. CuSO4 means copper sulfate. Copper sulfate in first beaker, and in the second beaker I am collecting again the copper sulfate. In the third beaker I am selecting zinc sulfate, ZnSO4. ZnSO4 is zinc sulfate. In the beaker D I am collecting FeSO4. FeSO4 means iron sulfate. Iron sulfate. And in the beaker E, I am collecting again ZnSO4. ZnSO4 means zinc sulfate. So, within these 5 beakers, I am collecting different types of mixtures. And after that, I am going to put certain type of metals in these beakers. And just look which are the metals I am giving. In this, I am putting zinc granules. Zinc granules. And in the beaker B, I am putting one iron nail. One iron nail. Iron nail. In the beaker C, I am putting one copper piece. I am putting one copper piece. And in the beaker D, I am selecting again copper. And also in the beaker E, I am selecting iron nail. So here now you have 5 beakers. It is having different types of solutions, and also we kept different types of metals in this. And you can see this diagram in your textbook in the page number 50. When you observe the diagram, you can see that in the first diagram, they just gave particular color for all these solutions, and after some time, they also gave one more diagram, and in that diagram, they just shown that after some time, what change will occur to these diagrams. So, when you observe, you can see that for this beaker A and beaker B, there occurs change in the color and all. That means there occurs particular reaction. And what about the C, D and E? When you observe the diagram, you can understand that here is having no such changes occurs. That means there is no reaction occurs for this C, D and E. But here there occurs certain type of changes. And now we are going to focus in this A and B. Now we are going to discuss it in detail. Just put in mind that in the beaker A and B there occurs reaction. And for this C, D and E there is no reaction occurs, and that's why it will remain as the same as before. Now we are just focusing on this A and B. So our first beaker was like this. We have the solution copper sulfate, and the metal is of zinc granules. At the initial stage, you can see that the solution was there in blue color. It was there in blue color, and we are just keeping this beaker for some time. That means we are just leaving it undisturbed for some time. You can see that this blue color will turn into colorless. This blue color will turn into colorless after some time. And also you can see another thing is there deposited in this beaker as red color. Red mass, something is there formed. And actually what it is? The red color that gets deposited, the red mass or red color, red mass that is got deposited at the bottom of this beaker is what? Actually the copper. Now the question is, why this color change occurs here? The color change occurs because the first thing is that there occurs one chemical reaction. Now we are just going to write what is the chemical reaction that occurs. We can represent the equation like this. This copper sulfate solution is getting reacted with zinc. We get the output as, or the result as ZnSO4 plus copper. That means actually here happens is this, when this zinc and the copper sulfate, actually this zinc is what? A metal. This zinc is a metal, and this copper sulfate is what? Metal salt. Metal salt, and this copper sulfate is in the form of solution. So we can say metal salt solution. So we have one metal and a metal salt solution. That means when this metal is getting react with the metal salt solution, then therefore certain type of substances, and the result is this. When this copper sulfate is getting react with the zinc, then the result is this. That means here the copper sulfate's copper is getting displaced and the the zinc is getting moved. That means this zinc displaces the copper. That happens in this. And when you observe this equation, you can see that this copper is and at the initial stage, what is in the solid state? Zinc. That means in the initial stage of the equation or the reaction, you can see that the zinc is there in the solid state. And after some time, you can see that this zinc is getting dissolved in this solution and the copper in this solution is getting deposited here. Simply we can say it like that. That's why we can see this red mass. That means the copper got deposited at the bottom of this beaker. That means the copper will turn into solid and the zinc should be go to this solution. That takes place in this reaction. So, no need of getting confusions or nothing. You just want to study this equation first. And you want to study this equation is the example for the displacement reaction. And also you want to study one more equation in this area. The first equation is this, the reaction between the copper sulfate solution and the zinc. When this copper sulfate solution is getting reacted with zinc, you get the result as ZnSO4. What is this ZnSO4? Zinc sulfate. Zinc sulfate and copper. Here this copper is what? Solid state, and here the zinc is in solid state. That means they are getting displaced. That's what takes place in this reaction. And now we are discussing about the Beaker B. This is what happens in Beaker A. And in the Beaker B, we just collected copper sulfate solution and we just kept iron nail. That is iron. So, at the initial stage, this solution is having blue color. And after some time, we are just keeping this setup undisturbed for some time. And you can see that after some time, this blue will get into pale color. That means it will get into dim or getting colorless. So, and also you can observe one thing. At the initial stage, this nail is in very clean or having the color of iron, you know that. And after some time you can see that the iron nail is getting a particular color of copper. That means this copper is getting deposited on this iron and this iron is moving toward our copper sulfate. That means there is occurs a transfer or exchange, or we can say it as a displacement. Now we are just writing the equation when the copper sulfate is getting reacted with iron. We get the result as FeSO4 plus copper. That means when this copper sulfate solution is getting reacted with iron, copper sulfate solution is getting reacted with iron, then the result is this. Finally, this copper in this solution is getting deposited in this iron nail. That is what this copper. And also this iron is moving to a solution. That is what FeSO4. FeSO4 is iron sulfate. Iron sulfate. So, this is all about the displacement reaction. Here occurs a displacement. Here a transfer is occurs between these two metals. Now, we discussed about the Beaker A. Then we discussed about Beaker B. Now the question is why there is no such reaction occurs in Beaker C, D and the F. What is the reason? It have particular reason. I already said that here we are selecting one metal and one metal salt solution. Metal and metal salt solution. Here we have two metal. So when this metal is more reactive than this metal salt solution, then there occurs reaction. When this metal is less reactive than this metal salt solution, then there is no such reaction will occur. That means when the metal is having more reactive than this metal salt solution, then there occurs reaction. For example, we just said that in the beaker B we have iron nail, and also we have what? A solution that is of copper sulfate. Here we can say that this iron is more reactive than this copper. That means here copper sulfate solution is copper. That's why there occurs the reaction. And what was there in the beaker C, D and E? We are just going to observe that. This is the reason behind this. That is, in the first beaker we selected zinc and copper sulfate solution. So here the zinc is more reactive than copper. That means the metal is more reactive than metal salt solution and there occurs reaction. And the second one is this iron and the reaction with copper sulfate solution. Here also the iron is more reactive than copper and there also the reaction occurs. In the third beaker we have zinc sulfate and copper. But here the problem is this. I am just writing it reverse. That means here we have copper and the zinc. When you observe here, you can see that this copper is less reactive than the zinc. And also in the beaker D, you can see that the copper and the iron again. Here also this copper is less reactive than the iron. And also in the fifth beaker we have iron and the zinc. Here also this iron is less reactive than zinc. That means these two are what? Metal, and these two are metal in metal salt solution. That means the solution. So when this metal is more reactive than this metal salt solution, there occurs reaction. And what about here? These are what? Metal, and these are what? Metal salt solution. Now who is more reactive? More reactive is what? There in the metal salt solution. That metal is more reactive. That's why here no such reaction occurs. That's why we are not seeing any type of change in the beaker C, D and E. This is all about this area, and this is what? The displacement reaction. So how we can define this displacement reaction? Very simple definition. A displacement reaction is one reaction in which one element is displaced by another in a chemical reaction. That means here we are displacing one element in another solution or another salt solution by a chemical reaction is what? Displacement reaction. There occurs a movement, or there occurs a transfer, or there occurs a displacement. This is what? Displacement reaction. In this area, first you want to study the definition. After that you want to study the two equations, that with the transfer with this zinc and copper sulfate, and also with iron and copper sulfate. And also you want to remember the reaction only takes place with the metal and the non-metal salt solution, where this metal is more reactive than this metal salt solution. This is all about this. And after this region, we have one topic called the uses of metals and non-metals. It we already discussed in our previous class, and so our chapter is over. You want to read your textbook 3-4 times and also want to complete your notebook, and we will meet in our next class with another chapter. It's enough for today. Thank you.